Hi class, today we're looking at Chapter 3, Lesson 3, Proportional Relationships. So proportional relationships are used for many things like cooking, chemical mixtures, medicines, and shopping. A proportional relationship is a relationship between the inputs and outputs in which the ratio of inputs and outputs is always the same. If a relationship is in a table, write the ratio of inputs to its corresponding output. If the ratios are the same, then the relationship is proportional. Let's go ahead and write down the definition. A proportional relationship is a relationship between the inputs and outputs in which the ratio of inputs and outputs is always the same. Okay, so now let's take a look. Distance versus time relationship. So determine if the relationship is proportional. So here we have the time, so 1 hour is 50 miles. So our ratio is 1 to 50. Okay. The second one is 2 to 100. The next 3 to 150. 4 to 240. So this one, 2 to 100, that can be reduced. Divide both of them by 2, you get 1 over 50. 3 and 150, 3 hours, 150 miles. That can also be reduced to 1 over 50. We're looking proportional, but then we end up with this one, 4 to 240. Divide those by 4, that equals 1 over 60. That is not, 1 over 60 is not the same as all these, 1 to 50. If it had continued 1 to 50, then the relationship would be proportional. But because we have that next one that says 1 to 60, the ratios are not all the same, so the relationship is not proportional. So our answer is no, they are not all proportional. Now we're going to look at some comparison shopping. So this is something that you could use on a regular basis if you are going to the grocery store. So determine if the relationship is proportional. So we have 2 pounds for $3. So our relationship is 2 to $3. That's our ratio. We have 4 to 6. Those can be reduced. We divide them both by 2. We get 2 to 3. Oops, those look like they're the same. And then we have 6 to 9. Both those numbers can be divided by 3. 3 divided by 3 is 2. 9 divided by 3 is 3. When you look at these, all of the ratios are the same. Therefore, this is proportional. Yes. The ratios are the same. Okay. Go ahead and you try the next two on your own. Come back when you're done. Okay, so for the first one, you should have got the ratios are not the same. And the second one, the first one you got, yes, the ratios are the same, right? They're all, the outputs and inputs are 1/4. The relationship is proportional, so the ratios are the same. The second one, there wasn't any correlation between them all being 1/2 or anything like that. So no, the ratios are not the same. Okay, so now we're going to look at input-output tables and graphs. You can graph a function with a proportional relationship by making an input-output table. This can help you organize your information you're given. So Jenna earns $12 per hour making bracelets. She uses the function E equals 12H to track her earnings, where E represents earrings and H represents the number of hours. Make an input-output table and graph your results. Does the function have a proportional relationship? Explain. So the first step is to make an input-output table. So, and you just choose values of H and solve for E. So she chose 1 hour, 2 hours, 3 hours, 4 hours. And then you plug that into this equation. And the first one you get 12. The second one 24. Third one 36. Fourth one 48. So you can look at this and say 12 times 1 is 12. 12 times 2 is 24, and so on. If you were to look at the relationship of this, right, you could have 1 to 12, oops, wrong thing, 1 to 12, 2 to 24, we divide that by each of those by 2. You get 1/12. My gosh, I keep forgetting the 1. 3 to 36. Divide each by 3. 1/12. 4 to 48. Divide each by 4. 1/12. Therefore, all of the proportions are equal. This can be shown in a proportional relationship by checking that all the ratios are the same and are equal to 1/12, and we just did that. Now we can sketch a graph, label the axis using H. So here's H for hours worked, and E, here's E with titles. So automated earnings in dollars. Amount earned in dollars. Plot the points and draw a line through them. So 1 to 12, here's 1 up 12, 2 to 24, 3 to 36, 4 to 48, and then we just connected them all. That is how you graph it. Okay, you try this one. The function T equals 4m gives you the temperature T in degrees Celsius after m minutes of a liquid during a science experiment. Determine if the function has a proportional relationship. Okay, so this is what you should have got. I created a table chart. I should have put the minutes on the other side, just so that it was consistent with the 1, 2, 3, 4 on that, but it's the same information. So for 1 minute, the temperature is 4, 2, 8, 3, 12, 4, 16, which is all a 1/4 ratio, which means it is proportional. And so then I did go ahead and graph it. So for 1 minute, it was up to 4, 2 up to 8, 3, 12, 4, 16. Notice I just knew what numbers I needed to use, and I placed those, the 4, the 8, the 12, the 16, 20. I didn't do 1 through 4. You don't always have space for that, so you just need to get down the information that you need. So our homework for tonight is page 94, number 5 through 15 odd. Happy homeworking!